In the beginning, it was dark. Without anything in existence, a void shrouded the universe. But then, in a vibrant explosion, there was light. Hot bodies of plasma spewed forth electromagnetic radiation into the void, somewhere between the ionizing gamma rays and the massive radio waves sat a small spectrum of heavenly, visible light. As humans, our visual perception is key to our understanding of the universe. Our eyes are intricate lenses which process waves of radiation into visual stimuli. Through an aperture, called the pupil, light waves enter the eye where they strike a thin membrane of cells. This membrane, known as the retina, contains cells specifically tuned to sense the visual spectrum of light: rod cells and cone cells. Rods sense the intensity of light, or the amplitude of the light wave. A variety of cone cells sense the range of different wavelengths within the visual spectrum. There are 3 different types of cone cells. One type senses blue light at the high end of the spectrum. Another senses green light in the middle of the spectrum. The last type senses red light at the low end of the spectrum. The absence of stimulation to the retina creates a sensation we refer to as black. Upon viewing light from the sun, the full range of the visual spectrum appears as a brilliant white light. In between a complete lack of light and the full illumination of white is the range of different colors that humans can perceive. When light of the visual spectrum comes in contact with matter, one of 2 things can happen. Either the light is absorbed into the matter, or the light is reflected off of the matter. Different wavelengths of light behave differently when they strike different types of matter. The reflected light is how we perceive the color of an object. The red petals of a rose contain red pigment. When white light from the sun strikes the red pigment molecules, the blue and green light is absorbed into the rose. But the red light is reflected. When that red light reaches our eyes, it stimulates the perception that the rose is red. In most situations, color is static, inherently defined by a material's composition. But humans are dynamic creatures. We crave new information and stimuli outside of our natural environments. Since the inception of our species, we have discovered methods of manipulating color. Over 40,000 years ago, in the western parts of what is now France, early humans decorated cave walls with ash and minerals. They took the colors that they observed in the natural world and replicated them with pigments. Without knowing, these early humans were employing subtractive color. You probably do as well. When we apply pigment to a surface in the form of paints or inks, we selectively absorb wavelengths of light to achieve a desired result. A sheet of paper reflects most light back into our eyes, which gives paper a white color, a blank canvas reflecting all light back. Different colored pigments absorb different wavelengths of light, subtracting that wavelength from the range of reflected light. Cyan pigment, magenta pigment, and yellow pigment are the 3 primary colors of subtractive color space. They subtract red, green, and blue light respectively. The presence of these 3 pigments absorbs all light, producing black. The combination of different ratios of the primaries can produce the variety of colors within the visual spectrum. One can create any range of visual stimuli. Pigments in physical media have existed as the key to manipulating color for millennia. But once the pigment is set, the color remains as static as the petals of a rose. As humans have evolved, the need for an even more dynamic method of handling color has emerged. So far, we've only focused on white light, the light that the sun emits. For much of human history, this was the only light that humans interacted with. This light contains all wavelengths of the visual spectrum. But suppose you could isolate a specific wavelength of light to observe. This is known as additive color. While subtractive color relies on removing wavelengths from white light, additive color works in reverse. From nothing, or black, color is added one wavelength at a time, ultimately producing white light when red, green, and blue light are mixed in equal ratios. Likewise, different ratios of red, green, and blue light can compose any color of the spectrum. The additive primaries are red, green, and blue. Each directly stimulate one of the 3 different cone cells. With just these 3 colors, we can create the perception of any perceivable color. This is the basic idea behind televisions, projectors, smartphones, and the screen that you're watching this video on. Color is information. It is the stimulation of radiation that creates hallucinations within our minds, such hallucinations that define our understanding of the world. The human manipulation of color is the manipulation of hallucinations, the manipulation of understanding within another's mind. But that is another story about how color is crazy.